I accidentally started my stream with normal camera on. Oops. That's okay. Set the notification out. Bitrate is lower than recommended. Stream bitrate of 28 kilobits per second. My internet's running fine. Still not running low bitrate. Output. Bitrate's different set really low. That's 28. 1600. Why? Oh, that should do that trick. So hopefully that will fix that warning. So I can switch to desktop, I think. Oh, turn that off. There we go. It's happening in the corner. Hooray! YouTube got rid of the warning. Nice. That's running properly. So this is the design work on the ATM machine. So it's actually imported 3 of the single gantry. Which actually, I'll open up the single gantry. The idea being that this ATM machine is essentially modular, using off-the-shelf 3D printer parts for a large majority of this. And then just designing any 3D printed parts to be durable, long-term parts, and ideally making as many parts static so that they can last a while. And then like bigger mounts and stuff are done with components that are common for extrusion systems. And everything's common length, so like underneath here you have a standard NEMA motor. It has a coupler, and an 8mm shaft, and then you have the GT2 belt pulleys. There's bearings in place which will get encapsulated in a 3D print. So the bearings are taking the brunt of everything, and it's fully supporting. This shaft is a commonly purchasable shaft that is known length. A lot of these aluminum extrusions, they're all known lengths. Trying to make as many components use the same size parts so that you're not buying numerous different sizes, you're buying all the same size. You have these parts up top here that can do the tensioning on the belts. So the motor drives down low, keeping the weight low. Belt comes up and around, and it moves this main gantry up and down. You have a smaller motor assembly, which there is a plate you can buy that mounts to this. I'm not sure if I actually have it modeled or not. No, I don't currently have it modeled, but there is a plate you can buy that mounts to the end here and will hold this NEMA motor. And this is a slim NEMA. It's not expected to move a lot of power or weight, so I'm hoping that the slim motor will work here. Slim motor is also being used. Is that a slim? Pretty sure that's a slim one. Looks slightly different. Yep, that's a slim motor. The main conveyor belt is also being run by a slim motor. Coupler GT2 belts will make up the width of the conveyor. Will probably be a 3D printed rail of some sort, or just get some aluminum stock bar and make mounts or a plate so that it has rails and the card stays between the belts. Runs along the belts. You got bearings on the shaft. The 3D printed assembly will hold it in place. So this gantry, it's still to be designed, is going to be some way of picking up cards and moving them. The idea being there'll be a set of shelves here and on the other side of it. And you want to try and minimize the space those shelves use. So the plan is to try and make it compact. The one thought I've had and plan to experiment with is the use of a vacuum pump. Normal attachments for sucking are actually really large. So I'm going to try and use some 3D printed TPU and design one that can be really slim. And then the other complexity is the fact that this plate, whatever is attached to it, has to be able to reach out and come back. Ideally do the same on the other side, so that you can pull cards from both sets of the shelves, bring them back and put them on the belt, and they can go back into position. And because of the needs of who I'm building this for, the idea, I don't need to save that, is that I use more than one. And if they ever outgrow it, it wouldn't be too hard to expand the machine and build onto it. so far, my estimation, 3 gantries should be more than enough. So this not only imports the main model, but starts adding all the extra pieces that allow the motors to have bracing and builds out the bracing for the main cross members that hold all the gantries together, and you have mounts along the top that can hold the tops of the gantries from moving, so that hopefully everything can be rigid and work effectively. And then what I started working on the other day, and I got a fair amount done, was this system. This wound up mounting to one side of the machine. So I have a gantry just in place to line things up properly. But the main portion of it is, let me turn off that. The main portion is this assembly here. So it extends the machine even further. And initially I was going to take in codes from this side, so you would stand this way at the machine. But I realized in terms of space saving and whatnot, I feel like probably better use this section. But granted, I'm just thinking if I measure from there, 220 millimeters, which is definitely more than system that's going to go in place there, but it still helps with the overall compactness of the machine that's going to get built. So instead it's designed this way. So you have this motor and belt assembly that can pull in a card into this slot and turntable. Turntable has its own 3D printed mount assembly. It still needs work. I'm pretty sure it's 2 separate parts. So they still need work. The bearing still has to be implemented into it. The other thing that has to be done to this is there has to be a bit of a track built on this turntable, so that there'll be a mount that comes from this bar with a roller that will ride along that track. So as it starts to turn, you can see this bar is on a gantry. So as it starts to turn, it'll lift itself up and pull itself away, because otherwise you'll have these wheels rubbing right against the cards. It's going to have issues trying to turn itself. And so as it takes in a code, you can load the code, start turning the code, take in more codes, keep going around. As it comes around, now initially it would have just went one space and immediately ejected it, and I could reverse it. We'll see how things go. To reverse it, I would just have to change the position of this opto sensor. So this sensor can tell it there's a code here, so it knows when the code is fully left the turntable. This curve is specifically designed to stick within the parameters of a gift code being bent but not destroyed. It will likely need a second motor along it to spit the code out the full distance, maybe 2 motors. Well, you could use 1 motor and a belt drive, but when it comes out, you'll have to build some walls around it so that it drops into place properly. But you can see here there's a motor for a conveyor belt, so this drops right onto the conveyor belt, and then it will enter the main row of machines. But instead of just 1 gantry, there's 3, so the machine decides where to stop it along the belt to be loaded on a shelf. You can also see another one of these S curves, and this right now is just a placeholder. As you can see, it's conflicting where it hits. So what has to be done is another component that I'll show in a moment. But it's what's going to happen is when a code is pulled from the machine, it comes back onto the main conveyor belt, and instead of coming back to this section, instead it's going to continue out. Which, as I'm thinking about it, initially the reason for that is because it could continuously rotate. So if it accidentally pulled the wrong code, it would know that it has the wrong code and it can just send it back. Because if you try, or even if you wanted to continue loading codes while it's prepping codes to leave, it could theoretically do that. But I'm realizing you're probably not loading codes while codes are being taken. Although the plan was to allow for that functionality by not using the display that's on the machine, but rather allowing extra laptops to be plugged into the machine while in peak season, so that people can use it effectively. That would have to be revisited, but continuous belt is typically the nicest in this application, I feel. So rather than codes coming back down this belt, they would continue to the end and drop down to a lower belt. And that lower belt is going to come back to this area. And it's going to have to go through a read-write mechanism that can tell exactly which code you have. And then once it knows the code, it'll send it back up to this belt. The idea being this part is going to get redesigned so that it actually goes low enough to capture that code. So it's going to have to be much larger. But also what it will do is if the code comes up and it's the wrong code, it'll drop it onto this small section of belt and immediately reverse it. So you'll design an opening here. So a code can come up it, but it can't go back down it. Instead, if it starts traveling backwards, it'll come out back onto the main belt, and the code can be put back on the shelf, and then the system will go hunting for the correct code that it was supposed to dispense. But if it is a correct code, it can drop it right onto this belt. Belt can spit it out into a hopper, so there'll be some sort of catch basin, and it'll be on a slant to bring it to the front of the machine. The reason I haven't fully finished this design is mostly trying to figure out all the components that are going to be necessary to build a good bill of materials and cost price point, which takes time to come up with. And there's going to be so many 3D printed parts that'll have to take time and refinement to do. So I'm just trying to get most of the main components. One of the next pieces is when a code is entered in the machine, you need to know which code it is, which leads to this assembly. So I have a separate assembly that's just this belt, but this is the full assembly that I've started. I have not kind of designed the full entrance of this assembly, but there'd be a way for the code to enter that's a little more human friendly than this 1mm slot. So you enter code. There'll have to be some motorized wheels at the front here so that the code ends up on the belt. And the reason for a belt is because with a magnetic reader, you have to have some force pushing the belt through. So if I'm pushing a belt through, or trying to move a belt through, well, you could use the rubber wheels. The problem with the rubber wheels is they've started making quite a few gift cards that have barcodes or QR codes instead. Well, if you want to use one of those, you run into the issue of mind blank. The wheel would be in your way unless you had the wheel on the underside. But then you have to push the code up against something without it flexing too much, and it'll become a hassle. Oh, what it? I'm pushing it up. I think it'd be a hassle because if you still wanted to do magnetic read, let's just separate it. Might have to play around with that. So what I'm potentially thinking is because of how long this is, it might work where you have rails like this and motorized wheel on top, and the magnetic reader can come and read alongside it, um, and still push a code through. And so instead of reading and scanning in one spot, you can move the barcode scanner further down and just move the motorized wheel to the underside of a rail system, because you can't do both on the same side without running into issues of the codes flexing, because the magnetic strip is too far to the side. Look, let's see. Got a few codes here. Been collecting codes for this very specific purpose. Yeah, a lot of these are still really close, because you'd want wherever the motorized wheel is where you'd want there to be pressure directly on the other side. That one's not bad, but that one, there's no standard. The only standard is the magnetic strip is always in the same spot on cards. But then some codes have barcodes, some don't have barcodes, and some have started using QR codes, but they never put them in the same spot. Like this one card from Amazon has 2 barcodes, so you'd have to know the standard for each and read them accordingly. This one doesn't have a barcode at all, it's purely a QR code. That one's a pure QR code. There's no standard between cards where they place the reader. Yeah. So it does appear that my idea of using this belt drive is going to be the preferred mechanism, just because cards are so different and they are changing ongoingly. And it's probably why kiosk-based machine readers that you can buy online cost an arm and a leg. And the other issue with those ones, because they start in like the $600 range, is that they typically only do one function, which is magnetic reading. If you're lucky, they'll do RFID as well, but they're not designed for barcodes and QR codes and stuff. I find the barcode data and QR code data is a little nicer to play with than a magnetic reader, and a magnetic reader would has a limited life cycle, so the less you have to replace the thing, the better. So the idea is that the magnetic reader head will actually be able to flip out of the way, and there'll be a gantry that sits here and can run back and forth. The module I have for reading a QR code can read barcodes. The issue is to read a barcode on a gift card. That reader would have to be a huge distance away But then to get it to read the itty bitty QR code, it'd have to be really close. So it'd have to move all over the place. And then you have to program that data in. And if you're trying to learn a new code, try and train it. Whereas for barcode, I have a different module made by the same company, but it's laser based instead of camera based, and it works flawlessly for the barcodes. So the plan is to use two different modules, keep them lower to the code so that this unit can remain compact, um, give it some leeway for movement, um, and then the idea is it can move back and forth so that it can move along the distance of a code, no matter where the issue is. So that's an example of the code. So you'll notice this height is not all the way over, whereas on the other side, it lines up perfectly, and this 3D printed part fits with a tight tolerance. Well, it's a 3D printed tolerance because this belt will be 3D printed. So it's not something a code will get stuck in. And the reason for that is so that it's a known good edge for a code to travel on. And then I'll end up making the same kind of wall on this side. This one is static, but this one is designed like this so that the edge that I build here will sit flush isn't the word. It'll be spring loaded. And the reason for that is I want to push the code towards the solid edge. Push it towards the edge, and that way the magnetic strip is in the optimal spot for the read head, which I'm sure will take tuning. But yeah, it'll be a lightly sprung edge. The edge that's here to there is optimal for most codes. It shouldn't be much larger than that for code specifications, but this will help take up any small amount of slack that is there. And the reason for the cutout is for a design that has not been finished. Some of these links, what needs to happen is they need an edge on them, like basically a T coming right off it, perpendicular to this plane. And the idea being is that's what's going to push the code along. So as a code comes into position, magnetic redo drops into place, the belt starts moving, and it will physically push a code through at the desired rate. And so the initial design for the belt I got from a model in Thingiverse, but I severely beefed it up. I was using 3D printed axles. Instead, I'm using cap head screws. There's enough plastic to kind of encapsulate everything, so there's no rough edges. I was there chamfer some of these edges and make them nice and not have 90-degree corners on them. Also within, I'll just show it on the main model here. Also within these links is the main bulk piece that connects links to each other. So there's a screw coming all the way through. Heat set inserts, and this kind of pathway follows all the way through the tube, so it's hollow inside and You can use longer screws if necessary. Might dab a little bit of Loctite on these. I'm not sure. It probably will need it, considering it's going to be moving, and it's probably going to try and back off these cap head screws. Hoping this design will allow it to be more durable, and you can kind of see the sprocket sitting in there as well. So the sprocket fits within the links, and the links themselves become the way to move it. You can see the end of that link. So once the links are together, that provides a space for the sprocket to fit. But it's designed so that it gets captured on both sides, so that it tracks correctly within the sprocket. And the sprockets also have bearings in them. Again, trying to keep up that durability rating. The other idea will be it has a G2 pulley on one of these sprockets. And so one of the things the original model did is it had not necessarily a bolt, but it had a tensioning mechanism around the shaft. And that's how it tensioned itself. And the motor was all attached to that assembly. Because I'm using a belt, obviously I want to tension both the motor and the main belt. So in our main assembly, the motor get bolted into place, you put the belt into place, and you try and find an equilibrium to pulling this shaft to the direction, which will tension both the motor and the main pulley. And if necessary, I can do adjustments from there. Although I'm hoping that it remains a simple task to maintain it. The only potential issue, obviously, I see long term is these links trying to wear against themselves. A little bit of grease will probably help. But it may come down that at some point I'll have to redesign, and this is the bonus of the modularity of this system, is that I can redesign this whole module and maybe design, and I may do it in advance, design these links to be even larger and have bearings in them, miniature roller bearings. Either a roller bearing or plain bushing. Because a bushing might work too, to be honest. And a bushing would be a lot less complicated to implement in this. Don't need to save that. So one of the next things is going to be this platform needs to be on the other side as well, because we need to capture cards coming off the system. I'm fully suspecting if I have a wheel here, let's import one of these rubberized wheels. These wheels come in different sizes. The one that I was modeling around, don't think I saved it, to be honest. I think I custom made it. I had to design it from the files. Which size wheel is this one? 60. So the D60 was the smallest wheel I saw that had a 8mm shaft on it. But get them as small as I think like 30 or 40 millimeter diameter. I'm pretty sure those ones use a 6 millimeter shaft. So we'll save that component. Which makes it a little easier. I thought I was going to have to copy it all over. So I would want to do top-down view. So wheel would sit roughly there. Mostly touching. It'd have to be on spring-loaded assembly. So you have the wheel there. The issue I worry about is that the card would essentially. I can get it closer. If I make the contact patch near there, I'm wondering if that'll put the card far enough forward for whatever mechanism comes through on the link. Let's see. Let's remove the card. That'd be essentially where the code would stop. Slightly past it, maybe. The code would be roughly there. I think I need to work on the belt being controllable. I can make the belt rotate. And I'd be able to test that dynamic. So that'd be something. And that's why this chain link is still here. It means it's linked to that other module file. So let's go back. Okay, open the conveyor belt. And so I need belt design. This link here. Create a copy. Let's see. Off. Making copies for all the components, but I want them as their own thing, and eventually I'll make it an assembly item, as a few of the links will be replaced with this one. So what I want is to design on this edge. This is 17.7. So 17.7 divided by 4. That's halfway. Like 5 millimeters tall. Make it so that it tries to capture the code. Let's see. So that captures that. If I come back into here, I can kind of see how it's going to play out. So it's already warning me that it's out of date. So let's get the latest version. So it's not tall enough. If I do that. And thinking I'm going to want it all the way at the back. Yeah. And I already knew I was going to have to cut it to fit the window, but yeah. So move it all the way to the back, and it's going to have to be significantly taller. So even in this position, by the time the belt actually loops around, it's going to be pushing on the underside of the code. So we come back to our sketch here. Actually, let's undo that. 10 millimeters. Let's go 4. I think that might work. So that'll put it in the correct spot. I think it'll work. Should probably be more curved than a flat plane, but the testing for that will depend on how it does as a movable model. So let's see. But I need that to be a component. Let's make a new component. Push. Oh, activated it. What? Shouldn't be S. Oh, we named these. Yeah, okay. Push like there. Move on the components for it. Oh, I had defaults to do that. Part of the reason for the embedment is I could turn off entire segments. But the trick, I think, it's gotta do joints for everything. So, joint. I'm gonna turn off that link. Probably gonna have to access all the links. What? It's ignoring my keyboard. Probably should have put hardware in its own component, although I don't expect to have to adjust it too often. You'd have to build animations for all those components too. Maybe. It's technically attached to the component, so maybe it wouldn't automatically assume rigid. Step 1. So next up, so this joint is wrong too. trying to watch another video because I suspect I'm not entirely doing this the right way. It would appear that making chain links work is complicated. It might just be better off animating just the one segment. So let's try animating. The start of making it work properly. I'm going to delete these joints though. At least let me see how it will behave. Here. because ideally I want to keep things moving. Like, there are ways of updating and testing things later. Because the general idea is to have a bill of material ready. Now, granted, this one would be going straight. So, yeah. It's going to dig into the code. So that would capture the code. Smack. Push. So, in theory, that could work. Probably want to make it a smoother transition than just sliding right down, but so one of two things would happen. Put two smaller wheels and move the wheel forward more so that it's essentially on the belt by the time this link is coming and pushing. If I make a copy, spy with a copy, it's tight. Yeah. It's probably going to want the 6mm version. I have the filament. I should get my 3D printer up and going. But worry a lot about the flex there. So as that comes around, it does hit the code. The only way to really, yeah, it goes right through what the code is. These motors, you wouldn't want them direct drive because you need them to be spring loaded. So they're going to have to be on a belt. So if you have multiple sets of motors, or multiple sets of wheels, you can belt them all together. Put a motor and a plate on one side. Can't put a motor directly here because it would conflict with a read head. Put a long shaft here, comes to the motor. Pretty much the only spot to put it. So put the motor over here. Oh, it's supposed to be a copy. So let's go looking. Right, I need to check the size. Seems to be lower on my wish list than I expected. What? Should have seen it by now. Oh, here we go. No, it's chains, belt. Man, I've got a lot of things on my wish list. It's so weird. Go back to the top. I'll try this again. Plates, parts, more parts. Because I'm totally surprised I have parts on my wish list. RFID, sample packs, LCDs, e-ink displays, DMX, lighting. Hey, I found them. .30mm diameter with a 6mm hole. And I think the best way to do this is to copy that and adjust its sizing. Turn it off. Okay, so start with the center input. Needs to be a 6mm shaft. Should probably check all the dimensions here. That's 30 millimeters. And then it's 2 millimeters. 8 millimeters. Yeah. That is a 30 millimeter wheel with a 6 millimeter shaft. It seems absolutely massive. That is 12.6. Well, I guess it'll be time to end this very shortly. D30 encoder. I wish it would stop activating parts. And we can save copy as 230 encoder wheel. Add it to that folder. But now move it to position. Let's see how much smaller it is. And this points out issue number 2, which is the shaft is in the way. So more adjustments will have to be made. So the adjustment of that aluminum has to move. And the height of this will have to change. Granted, there's going to be aluminum on the side of the rail too. But yeah, much more manageable now. Putting a second wheel here and 2 wheels down at the end. And in the center section, you can have all the scanning and such. The idea is this wheel will have to move further over. And you want it to have something solid to go against. And that way, it can move it fully onto the belt. And create a copy. Let's show 80 millimeters. Standard code is 86. I need more than one. Or more than 2, sorry. Do it at 30. Do another one. $50. It's at 40. So this one will change this opening. So, coming in late there, Keith. I'm about to shut it down. Gotta take a quick flight over to Australia now. But been working out mechanics for this belt drive assembly. So I partially made the chain adjustable. To make the full chain motion control is a lot of work, so I haven't done that yet. But initially I was using one of these rubberized wheels, a really large one. But because of the gap between where the belt starts and where this rail ends, the card obviously would stop roughly there. And the idea of the belt is that it pushes a card along, because there'll be things in the way that prevent you from putting wheels all the way along, both either top driven wheels or bottom driven wheels, and having the card on a rail. So the belt is the best way to do it. And the belt will have kind of these pushers. But even with the pusher, it's not fully guaranteed that it grabs the card, let alone grabs it nicely. Nope, that's the wrong mechanical link. Let's grab this job. So when it rotates, it can grab it. Now this wheel wouldn't be there if you wanted to grab it like that. You can see it's going to bend the card a little as it's trying to move the belt. The only way to really fix that would be a belt with smaller links, but it's not entirely an option in this design. I'm realizing I have to fix that because that is in the way of that arm. Right. So that'll be because the larger wheel doesn't have this issue. Although I can probably use one larger wheel and these two smaller wheels. Yeah, so with the wheel being here, this card would be much further along. It'd be less of an issue for this arm to come up and start pushing the card along. And then there'll have to be wheels on the other side. All the card reading can happen in here through numerous mechanisms. This motor will end up connecting to shafts via the belt to move these 3 sets of wheels, because these wheels will have to be on springs. So belt drive is the best way to do it, and then you got your belt drive for the chain drive underneath. It's quite the complex mechanism, and that's on top of this monstrosity. So yeah, chipping away at it. I have the larger assembly mostly ready. The idea is to try and build a quick bill of materials to have an idea of how much it's going to cost. Obviously, can't hypothesize everything until you start designing it, especially the ridiculous number of control boards it's going to need. But I want to try and get as close as I can to having everything working or modeled. I'm trying to stick to mostly off-the-shelf parts first, but having the card reader mechanism is quite the mechanism that it needs to work. So, but I'm gonna shut it down, and I'll see people in a hot minute over in Australia. Go watch Superhouse. Dum, dum, dum.